Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some basic theorems, that is Rolle's theorem and Lagrange's mean value theorem in application of a derivative. Rolle's theorem. Statement. What is the statement of Rolle's theorem? If a function f is continuous in close bracket AB, second point, differentiable in open bracket AB, third point, f is equal to FB, then there exists at least one point C belongs to open bracket AB so that f dash C is equal to 0. Only the statement in your course in Rolle's theorem. If a function f is continuous in close bracket AB, differentiable in open bracket AB, f is equal to AB, then there exists at least one point C belongs to open bracket AB so that f dash C is equal to 0. Clear? The statement of Rolle's theorem. Geometrical interpretation of Rolle's theorem. That means, what is the geometrical meaning of Rolle's theorem? It is A, it is B, x equal to A, x equal to B. X equal to C. At x equal to C, the tangent is parallel to x-axis. This side is FB, this side is FA. FA is equal to FB. This length is the same as this length. The tangent is parallel to x-axis at the point CFC. It is the tangent which is parallel to x-axis. x equal to b, x equal to a. At x equal to c1, the tangent is parallel to x-axis, tangent 1. X equal to c2, the tangent is parallel to x-axis. X equal to c3, the tangent is parallel to tangent 1, tangent 2 and tangent 3. In figure 1, it is figure 1 and figure 2. According to the statement, the first condition is the function is continuous in closed bracket AB. Here the function is continuous in closed bracket AB. In figure 2, f is continuous in, it is y is equal to fx, is continuous in closed bracket AB. Y is equal to fx. Differential in open bracket AB, fa is equal to fb. Fa is equal to fb. Here it is a point, it is b point, it is fb, and this height length is fa. Fa is equal to fb. This length is the same as this length. This length is the same as this length. Then there exists at least one point C belongs to open bracket AB such that f dash C equal to 0. There exists at least one point, means there exists at least one point, means either one point or more than one point where f dash C equal to 0. That means slope of the tangent at x equal to c is 0. That means tangent is parallel to x-axis. Here only one tangent parallel to x-axis. In figure 2 there are 3 tangents parallel to x-axis. Here there exists at least one point c belongs to AB such that f dash c equal to 0. At least one point, one or more than one, where the tangent is parallel to x-axis. Clear? If all three means first point, second point, third point. If all 3 conditions are satisfied, then there exists at least one point C belongs to open bracket AB such that f dash C is equal to 0. F dash C equal to 0 implies this. What is the meaning of f dash C? Slope of the tangent to the curve at x equal to C. Slope of tangent at C FC order pair is equal to 0. What is 0? Slope of x-axis. Slope of x-axis implies this. Slope of tangent is equal to slope of x-axis. That means tangent is parallel to x-axis. Tangent is parallel to x-axis. Is the geometrical significance of Rolle's theorem. Here, first question, verify Rolle's theorem for the function f defined by fx equal to x mod on close bracket minus 1, 1. Answer, the function fx is equal to x mod on close bracket minus 1 to plus 1. Here a is equal to minus 1 and b is equal to plus 1. Graph of the function. Y is equal to x, y is equal to minus x. It is the graph of the function fx equal to x mod. It is continuous everywhere. X greater than equal to 0, it is x less than 0. Clear? Fx equal to x mod is continuous for all x belongs to R. That means set up real numbers. That implies fx is equal to x mod is continuous on close bracket minus 1 to plus 1. The first condition is satisfied. Second condition, fx is equal to mod of x, which is same as x if x greater than equal to 0 minus x if x less than 0. Differentiating both the sides with respect to x, which implies f dash x is equal to 1 if x greater than equal to 0 and minus 1 if x less than 0. Clear? X mod is equal to x if x greater than equal to 0 and minus x if x less than 0. F dash x is equal to 1 if x greater than equal to 0. F dash x is equal to minus 1 if x less than 0. Which implies f dash 0 plus. That means right hand derivative at x equal to 0. What is the right hand derivative? That is 1. X greater than 0. The value is 1. F dash 0 minus. The left hand derivative at x equal to 0 is minus 1. That means x less than 0. The derivative is minus 1. Which implies f dash 0 plus is not equal to f dash 0 minus. Which implies f dash 0 does not exist. Clear? Derivative at x equal to 0 does not exist. implies f is not differentiable at x equal to 0, which is belongs to open bracket minus 1 1. Therefore, Rolle's theorem is not applicable for the function fx is equal to x mod on close bracket minus 1 to plus 1. Rolle's theorem is not applicable for the function fx equal to x mod on close bracket minus 1 to plus 1, since the second condition is not satisfied. Clear? Next question. Verify Rolle's theorem for the function f defined by fx is equal to s square plus 3x minus 10 on close bracket minus 5 2. Answer: fx is equal to s square plus 3x minus 10 on close bracket minus 5 2. Here a is equal to minus 5, b is equal to 2. Implies fx is equal to minus 10 into s to the 0, 3 into s to the 1 plus 1 into s to the power 2 is a polynomial function of degree 2. Here implies f is continuous on close bracket minus 5 2. Since every polynomial function is continuous. Clear? fx is equal to fx equal to 3 s square plus 3x minus 10, which is same as fx equal to minus 10 s to the 0 plus 3 s to the 1 plus 1 into s square is a polynomial function of degree 2. Implies f is continuous on close bracket minus 5 2, since every polynomial function is continuous. So the first condition is satisfied. Second condition, fx is equal to s square plus 3x minus 10. F dash x is equal to 2x plus 3 is exist for all x belongs to open bracket minus 5. F dash x is exist for all x belongs to open bracket minus 5 2 is true. Clear? So the second condition is satisfied. Third condition, f minus 5, which is same as 25 minus 15 minus 10 is equal to 0. f2 is equal to 2 square plus 6 minus 10 is 0. Implies f minus 5 is equal to f. So the third condition also satisfies. F satisfies all conditions of Rolle's theorem. So there exists at least one point C belongs to open bracket minus 5 2 such that f dash C is equal to 0. F dash x is equal to 2x plus 3. F dash C is equal to 2c plus 3 is equal to 0. C is equal to minus 3 by 2 belongs to minus 5 open bracket minus 5 2 is true. Clear? Therefore, verify Rolle's theorem for the function f defined by this. Therefore, Rolle's theorem is applicable for the function defined by fx is equal to s square plus 3x minus 10 on close bracket minus 5. Rolle's theorem is applicable for the function defined by fx equal to s square plus 3x minus 10 on this. Clear? Okay. Next. Lagrange's mean value theorem. Shortly, it is written as Lmvt. Lagrange's mean value theorem. Statement: if a function f is continuous in close bracket AB, second condition, differentiable in open bracket AB, then there exists at least one point C belongs to open bracket AB such that F dash of C is equal to F of B minus F A divided by B minus A. Lagrange's mean value theorem statement. If a function f is continuous in closed bracket ab, differentiable in open bracket ab, then there exists at least one point c belongs to open bracket ab such that f dash c is equal to fb minus fa divided by b minus a. Only the statement in your course. Geometrical interpretation of Lagrange mean value theorem. Geometrical interpretation of Lagrange's mean value theorem. F dash c is equal to fb minus fa divided by b minus a. X is equal to A, X is equal to B. It is A point, it is the B point. The coordinate of A are y is equal to fx. It is a continuous function. A, f. The coordinate of B are B, f, B. F dash C means derivative at x equal to c, that is slope of the tangent to the curve at the point c, which is equal to fb minus fa divided by b minus a. fb minus fa divided by b minus a, that means slope of the chord joining a and b is equal to f dash c, that means slope of the tangent. Slope of the tangent and the slope of the chord are same, that means parallel. X equal to c. It is C F C, and this point is capital C. It is parallel to the chord, that is tangent is parallel to the chord. If all conditions means first condition and the second condition are if all conditions, that means first condition and the second condition are satisfied, then there exists at least one point C belongs to open bracket AB such that f dash of c is equal to f b minus f a divided by b minus a, which implies that what is f dash c? Slope of tangent at CFC is equal to slope of the chord joining capital A, F, A and B, capital B, B, F, B. Clear? F dash C means slope of the tangent to the curve at the point CFC. And this FB minus FA divided by B minus A. Y2 minus Y1 divided by X2 minus X1. That means slope of the chord AB, which implies slope of the tangent at this. Tangent is parallel to the chord. Tangent is parallel to the chord is the geometrical meaning or geometrical significance of Lagrange's mean value theorem. Clear? F dash C is equal to B minus F divided by B minus A. It represents slope of the tangent to the chord at C. It is the slope of the chord joining A and B. That means tangent is parallel to the chord. Is the geometrical meaning of Lagrange's mean value theorem. Clear? Next question. Using Lagrange's mean value theorem, prove that sin x less than x, x belongs to open bracket 0 pi by 2. Answer. Let fx is equal to sin x, a is equal to 0, b is equal to x, and x less than pi by 2. It is 0, it is pi by 2, and it is x less than pi by 2. Differentiating both the sides with respect to x, f dash x is equal to cos x, f dash x is equal to cos x, where x less than pi by 2 and greater than 0. Is exist on open bracket 0x. Clear? Cos x is continuous on 0 to pi by 2. So f dash x equal cos x is exist on open bracket 0x. Now fx equal to sin x. F is continuous sin x is continuous on 0 to pi by 2. So sin x is continuous on close bracket 0x. f is differentiable f dash x equal to cos x. Cos x is exist on open bracket 0x. Clear? F is differentiable on open bracket 0x. F satisfies all conditions of Lagrange's mean value theorem. Clear? F is continuous on close bracket 0 to x, f is differential on open bracket 0x. So f satisfies all conditions of Lagrange mean value theorem. So there exists at least one point C belongs to open bracket 0x, so that f dash C is equal to fb. Fb means fx, fa that is f0 divided by b minus a that is x minus 0, which implies this. F dash c, f dash x equal to cos x. Cos c is equal to fx means sin x, f0 means 0 divided by x minus 0. fx is equal to sin x, f0 is equal to 0, f dash x is equal to cos x, f dash c is equal to cos of c. Clear? Since cos c is equal to sin x divided by x, which implies sin x by x is equal to cos c. Cos c, what is c? C belongs to c greater than 0, less than x. Cos c is less than 1. Clear? Less than 1. Which implies sin x divided by x less than 1. Which implies sin x less than x. Hence, proved. Next question. Prove that if derivative of a function is 0 in an interval, then the function is a constant in that interval. The function is a constant means the function is a constant function. Prove that if derivative function is 0 in an interval. Answer. Let fx be the function whose derivative is 0. Let fx be the function whose derivative is 0, whose derivative is 0 on the interval b open bracket. Let fx be the function whose derivative is 0 on open bracket ab. That implies f dash x is equal to 0 for all x belongs to open bracket ab. Clear? To show fx is a constant function. What is a constant function? Whose graph is parallel to x-axis. Y is equal to fx is equal to c. Is a constant function. The value at x1 is fx1 and the value at x2 is fx2. fx1 is equal to fx2 for the constant function. To show f is a constant function, which implies and implicit by fx1 is equal to fx2, where x1 not equal to x1 not equal to x2, but fx1 is equal to fx2 for the constant function. Constant function is parallel to x-axis. It is the x-axis. Here, to show fx1 is equal to fx2, where x1 not equal to x2. Given f dash x is equal to 0 for all x belongs to open bracket a. Let a less than x1 less than x2 less than b. It is a, it is x1, x2 and b. Given f dash x equal to 0 for all x belongs to open bracket ab, implies f dash x equal to 0. That means derivative exists in the interval this. Every differential function is continuous. So f dash x equal to 0 implies f is continuous on open bracket ab. That means f is continuous in close bracket x1 y1. Implies f is continuous. Every different function is continuous. On open bracket, close bracket x1, x2. And f is differentiable. Differentiable on open bracket x1, x2. Since f dash x equal to 0 for all x belongs to ab. That means f dash x equal to 0 in the open bracket x1, x2. Clear? F satisfies all conditions of Lagrange's mean value theorem. Clear? F is continuous on close bracket x1, x2 and f is differential on open bracket x1, x2. So f satisfies all conditions of Lagrange mean value theorem. Implies, so there exists at least one point C C belongs to open bracket x1 x2, so that f dash C is equal to f of x2 minus f of x1 divided by x2 minus x1. Clear? Which implies this. C belongs which implies 0 is equal to fx2 minus fx1 divided by x2 minus x1. Since C belongs to x2, x1, x2, open bracket. For all x belongs to AP, f dash x equal to 0. That means for all x belongs to x1, x2, f dash C is equal to 0, which implies this f x2 minus f x1 is equal to 0. Clear? C belongs to x1, x2, so f dash C equal to 0. Every element in the open bracket of AB, f dash x equal to 0. For all x belongs to open bracket AB, f dash x equal to 0. Since C belongs to x1, x2, f dash C is equal to 0, which implies this. F of x2 is equal to f of x1. F x1 is equal to f x2. Therefore, the statement is proved that therefore the statement is proved that clear.